In this video, we will explain you detailed how to work with stations. The station receives a part from its predecessor, processes it, and moves it on to one of its successors after the setup time and the processing time has elapsed. First, you need to start plant simulation and create a new model. To see the attributes of your station, double-click on the station in the toolbox. Here, the object dialog opens, and you can see the different procedure times of your station. For example, the processing time, which is the time the MU remains on the material flow object to be processed. It is the interval between the setup and the time the material flow object moves it to its successor. Here you can select a distribution from the drop-down list, for example, the log norm. It is a stochastic processing time. After selecting a distribution, enter the required parameters into the text box. We need to specify the following values: a mean processing time, a standard deviation, a lower bound, and an upper bound. We set a mean processing time of 55 seconds and a standard deviation of 5 seconds. The lower bound with 1 second is the smallest value that the distribution can take, and the upper bound of 1 minute and 30 seconds the greatest value that the distribution can take. For more help about the different distributions, you can have a look into the online help. Under the processing time, we can see the checkbox Automatic Processing. Automatic processing automatically start processing parts immediately after they enter the object. If you deactivate it, you have to start processing entering parts by using SymTalk methods. In the tab Failures, you can define failures for your object. For example, a main motor down. You can set a distribution for the start and stop and the availability of your main motor. Set the availability to 75% and the mean time to repair to 30 seconds. We assume that the main motor only has a failure when the station is processing something. Thus, the failure relates only to the processing time. Click then OK. In the Controls tab, you can manage specific controls for your entrances and exits. You can select a method object by clicking on Select Object, or you can create a new control method for your instance. To learn more about specific controls, refer to the videos 12 and 13. In the Exit tab, you can select your exit strategies from the drop-down list, according to which the object moves the part onto one of its successor. Typically, you'll employ an exit strategy to manage the distribution of material flow. This is essential when the operational sequence doesn't specify a single successor. Your goal is to select an approach that optimizes certain factors, such as cost or time. By using exit strategies, you enhance the efficiency of your production line. Now we will create a simple model to show you how to work with the functionalities of a station. To start modeling, we will build a production line by inserting a source, several instances of the station, and a drain. Then connect them. We want the station to transfer certain percentages of its parts to the successor stations. We want 20% of the output to go to successor 1, the station named Station 1, 30% to successor 2, named Station 2, and 50% to Station 3. To do so, open the station, click the tab Exit, and select the strategy percentage. We then click Apply. Now we can open the list. Type in the percentages. The first successor receives 20%, the second 30%, and the third 50%. Click OK. To realize the distribution of the parts regardless of the individual states of the successors, we have to select blocking behavior. The connectors are very important for exit strategies. They set the route of your plant. To find out the first successor of the station, we place the cursor over the connector between station and station 1. This opens a tooltip showing the successor number of the station and the predecessor number of station 1 of this connector. To be able to check the percentages more easily, we open the source. Enter an amount of 1,000 parts. Click OK and run the simulation. When the simulation finished, we can check the results. To do so, we select the stations and press F6 to open the statistics report. In the resource statistics, you can see the availability of our stations, and in the table Material Flow Properties under the column Number of Entries, the desired percentages. Now we set the availability to 100% by deactivating the main motor down, and we set the processing time of station 2 to constant 4 minutes. To check the effect of non-blocking behavior, deselect blocking in the first station. Now our station only moves parts to those successors which can accept one. Start the simulation again and open the statistic report. We see that the number of entries differs from the desired percentages because station 2 has a longer processing time than the other stations. As mentioned, you can use different exit strategies for your applications. To prefer a station with a special attribute than other stations, you can use the exit strategy minimum processing time. The station with this exit strategy moves the MU to the successor with the shortest processing time. Before you start your simulation, change the processing time of station 2 to constant 5 seconds. Run the simulation and open the statistic report. You can see that the number of entries of station 2 is more than the other stations because its processing time is less than the processing times of station 1 and 2. It is also possible to make your exit strategy dependent on MU by choosing MU attribute in the drop-down list and press Apply. Now our exit strategy follows the attributes of our MU. To showcase this, we need to create an attribute for our MU, so open the source dialog and select Sequence for the MU selection. Change the amount to -1. Now we need to insert a data table from the information flow. To do so, insert a data table into the model, then drag it into the dialog of the source. When we press Apply, the data table will automatically adjusted. We want a distribution that is dependent on our MU attributes. To do this, we create 2 parts with different weights. To create an attribute for our MU, we drag and drop it into the table. Select 100 as number and name our attribute X. Here a name must be assigned to the table so that the table can be created. You can choose any name you want. Insert a second part. Set the number to 50 and name the attribute Y. Double-click on the attribute X. Now Plant Simulation opens another table where you can choose and define your attributes. In our case, we want produce parts that weigh 10 kilos. We enter a name for the attribute and enter 10 in the weight column. To define an attribute for our second part, double-click on Y and enter a name of the attribute. Then enter 20 in the weight column. Now open again the exit strategy of our station. Change the attribute type to weight and click Apply. Then open the list. Attribute W1 has a value of 10, and we want only Station 1 to receive these 10 kilo parts. Click the Return key to insert a new row. Attribute W2 has a value of 20, and only Station 2 should receive it. To check the results, run the simulation and open the statistic report. As you can see, the parts were divided as discussed. 100 parts weighing 10 kilos were passed to Station 1, and 50 parts weighing 20 kilos to Station 2. Now we would like to show you parallel stations. They work similar to the normal stations, but the big difference is that the parallel station has several processing places as opposed to the normal station. In the tab Attributes of the parallel station, you can enter how many MUs the station should hold in its X and Y dimensions. If you activate the checkbox, then the processing of the parts will be started only if all places are occupied. Thus, all parts have the same working times. If you clear the checkbox, then each position works for itself, and the respective working times start immediately as soon as a part comes in. You can also define individual processing times for your individual places under the drop-down list of the processing time. You can also select when the recovery time starts. The recovery time is the time which is required to return a station into a defined state before it can start processing the next part. The default setting is when part enters. You can change it to when processing of the part is finished. Then the recovery time elapses after the part is processed, no matter if the part is still located on the station or has left it. Or the recovery time elapses after the part is processed and has left the station. Change the recovery time to 5 seconds and select when part enters. Replace Station 2 with a parallel station and change the processing time to 4 minutes. Now make sure that the connector structure has changed. Since the previous connector was deleted and another one was inserted. Change the exit strategy of the first station to percentage again, and enter the previous percentages of 20, 30 and 50%. 50% now go to the parallel station, since it was the third to be connected to the first station. Start the simulation and open the statistic report. You can see that the numbers of entries agree with the desired percentages. This concludes the introduction to stations, where we showed how you can work with stations using different exit strategies.